to re. So I'm going to put a problem on the board similar to yesterday. So I want you to find the two missing variables. All right, so we're going to start off by you doing a practice one. And then what I'm going to show you today is actually a simpler way to solve that problem and one similar to it. But sometimes you still have to use the similar triangles. I'm going to show you a way where sometimes you don't have to use the similar triangles. And then I'm also going to get to another proportion that's formed in triangles. So we're going to look at two different theorems today that help us write proportions with triangles or proportions with just lines and able to solve this an easier way. Okay, so let's start with an opening problem. You guys take like 2 or 3 minutes. Try and do this on your own, and then we'll go over. Greetings. So we're redrawing the two similar triangles. That helps. That helps with that. Helps you see which sides are proportional. Two similar triangles up there. Big one. The little one on the bottom. That you know. You need a piece of paper, or you want to do it there? All right. Yep. Oh. 4 is in the side of a triangle. You can't do 4. You can't use 4. You do 10. You have 10. 10 is a side. What's another side? Oh. All right, you guys ready? No. You even redraw the triangles? No. Triangle. Got the big one. And the little one. All right, this one was in here, and I just moved it over there. Whoop. This is 8. This is 9. This is 10. What's this length? 9 plus x. You got to add those pieces together, just like we're adding these pieces together, and we get 14. Now you can see the corresponding parts, right? It's this little piece to the whole thing. And this little piece to the whole thing. 10 over 14. 10 over 14. And 9 over 9 plus x. Little piece of the whole thing, little piece of the whole thing. And then we've got the 8 and the y that go together. All right. So if we're going big to small, the ratio or scale factor is 14 to 10, which we could reduce to 7 to 5 if we wanted to. So we got 14 over 10 equals y over 8. Or we've got 14 over 10 equals 9 plus x over 9. Okay, can you see the proportions? 14 over 10, 9 plus x over 9. 14 is this side in the big triangle over 10, this side in the little triangle, equals y, that side in the big triangle, over 8, that side in the little triangle. Okay, questions on setting up the proportions? Now you just cross multiply. 10 times y is 10y. 14 times 8 is 80 and 32, 112. Did I not do that right?
Yeah.
122?
112.
80 and 32, 112. So I get y equals 11.2. When you cross multiply here, 9 times 14, 90 and 36, 126. My math okay?
Yeah.
Equals 10 times 9 plus x. We get 126 equals 90 plus 10x. Subtract 90 from both sides. 10x equals 36. Divide both sides by 10, 3.6. Okay? All right, let me show you something. Similar diagram, right? Okay. All right. So I'm going to use those letters and set up the same proportion as I did here. All right. So if I do that, I'm going to have this entire length, which is b plus a over a. Just like we did here. We did 4 plus 10 over the 10. And then I'm going to do the same thing on this side. So I did this little piece to the whole thing. So now I'm going to do this little piece to the whole thing. Hold on, did I do that right? Hold on, I did that backwards. I did the whole thing to this little piece. Sorry. So I'm going to do the whole thing to this little piece, right? I'm setting up proportions with the similar triangles. The big side to the little side, the big side to the little side. You see that? We okay? So I'm just using variables now instead of numbers. And now I'm going to cross multiply. A times D plus C equals C times B plus A. Okay? Then I'm going to distribute. AD plus AC equals CB. What the heck?
Yeah.
Well, okay, plus CA. That's right. Okay. That's just some algebra. Now look at, there's a CA on both sides. So if I subtract it from both sides, it's gone. So what we have is A times D equals C times B. C times B. Too many letters that sound alike. All right. Okay. AD, CB. So like what this is was actually after you cross multiply a proportion. So watch what happens. If I put an A here, what goes here? The D, right? Because A times D equals AD. And if I put a B here, what goes here? C. B times C equals CB. So if you look at what just happened, and we compare it back to the now, if you don't understand all this junk that I just did here with the algebra, this is the main thing that we got to look at. Look at that compared to the diagram. A over B, this over this equals this over this. So what just happened here in all this is I simplified a way to find those missing parts, or at least one of the missing parts. This line right here is parallel to this line. Parallel lines divide things proportionally. They divide those other lines proportionally. So this forms a ratio that's equal to this ratio. You can just do this piece over this piece equals this piece over this piece. So we can come back over here to this problem right here, and instead of using the similar triangles, we can just say 4 over 10, this over this, because here's our parallel line, equals x over 9. This over this. One ratio, another ratio. Cross multiply. 10x equals 36. Divide both sides by 10. X equals 3.6. So it's a simpler way to find that variable instead of using similar triangles. All right, and then you're going to practice some of those today. So sometimes you have to use the similar triangles, right? In order to find y, you have to use the similar triangles. But if you have parallel lines, you can just set up quick ratios to find missing sides. And it doesn't just work in triangles. It works with any diagram anytime you have parallel lines. So, for example, if I've got these two lines right here, and I divide these with parallel lines. Parallel lines. Another parallel line. And let's do another parallel line. So I've got 4 parallel lines that are intersecting these two lines. What happens is these separate pieces all form ratios. Okay, this over this equals this over this. I can do this over this equals this over this. You just got to stay consistent. I can do this entire length over this little piece equals this entire length over this little piece. You can set up ratios with all of those just because we have parallel lines. It's called the side splitter theorem. If lines are parallel and they intersect other lines, it divides those lines proportionally. So I can come in here and throw some numbers in there. So let's say this is 8. This is 10. This is 12. This. This is 3. This is x. Oh, we can't have another x. Well, no, z. I like y. Oh no, I like y. Find x and y. We'll keep it a y. We'll keep it a y. We'll keep it a y. There's no way there.
Are you recording?
I am recording. for the people that have the vid, Uncle COVID, or if they're quarantined. What? I did that yesterday. You mean again? I just told you the entire story about what happened yesterday. I cut it out, and I only cut out the swear word. And I just have the video of the swear word. I should have just left it. Who cares? Like, it's not. I mean, they say way worse.
Got banned for saying
All right. So give me a ratio to solve for x. What ratio can we use to solve for x, Daniel? 8 over 10 equals x over 12. 8 over 10 equals x over 12. Cross multiply. 10x equals x equals 9.6. Give me a ratio to solve for y. Yeah, 10 over y, 12 over 3. Okay, let's say I wanted to find, okay, let's just do that real quick. 10 over 10 over y equals 12 over 3. Okay, let's say I didn't know this. And I wanted to find, and I knew this was, here, I'm just throwing some other stuff in here real quick. Let's just say that was, let's just hold on, it was 9.6. Okay, whatever, it's 9.6. Okay, and we had this set up, right? And I wanted to know what that whole length was. So now let's use a z. Give me a proportion to solve for z. Alisa?
8 over z.
Yeah.
9.6 over 15.
Yeah, right. 8 over the z equals 9.6 over 15. Just be consistent with those different parts. Does that make sense? All right, that'll make some of these problems easier now. Setting up a quicker, easier proportion to solve instead of using the similar triangles. Now, again, if you can only do this when you're given these lengths. If you're given any of the parallel lengths, then you have to use similar triangles again. And actually, in this diagram, we have similar triangles. These are lines, right? Lines continue forever. They would actually intersect here, and we would have similar triangles. See them? Yeah. Okay. All right. So that's called the side splitter theorem. All right. So that's one way to set up a proportion using parallel lines. The other thing we're going to do to set up a proportion is use an angle bisector. Here's a different theorem. This one's called the angle bisector theorem. So we're going to have a triangle and an angle bisector in that triangle. Okay, remember an angle bisector is a ray that divides an angle into two congruent angles. So there's an angle bisector. That angle bisector is forming some new segments here and here. It divides this triangle in half proportionally. A, B, C, D. A over B equals C over D. That side forms a ratio that's equal to this side over here. Now, can you give me another ratio, another proportion? Give me another proportion that's the same as that one. You don't just say the same thing. What I mean by the same is if you cross multiply, you're going to get the same thing. You don't understand? Give me a proportion that's the same as that proportion. So if you have that diagram, what's another proportion you can use to solve for missing sides? On them? And I want fractions. I want two fractions. Sophia. Yeah. A over C equals B over D. This over this equals this over this. Now, why is it the same? Cross multiply. AD, BC. Cross multiply. AD, BC. Same thing. This over this equals this over this. Give me another one that works. What? Are you saying something, Ryan?
No.
You weren't saying anything? Or you were just thinking out loud?
No.
I was hearing things? Hey, Jesus?
Never mind.
Ibuku?
B over A is equal to B over C.
Okay, yeah, just flip those around. B over A equals D over C. We're just saying consistent. B over A equals D over C. The side over the part of its side that's split, the side over the part of the other side that's split. So those all work because if you cross multiply, you get the same thing. What's one that wouldn't work? What's a proportion that you can't do to solve this? Aaron? Right, A over D equals C over B. You can't start crossing over, right? This side is forming a ratio, this side's forming a ratio. Or those are forming a ratio and those are forming a ratio. Stay consistent, just like we have to stay consistent with those when we set up our proportions. Okay, don't cross over. You can't do 8 over 12 equals 9.6 over that, right? You got to stay consistent with your ratios. Does that make sense? Okay. In the packet today, we're going to be working on pages 20 to 22. Pages 20 to 22. All right. We're not going to get through the entire thing, but let's try to get through like the first 2 pages. Tomorrow, I'm going to, I can talk about what we're going to do tomorrow, but just for the Zoom people that are going to watch on Zoom. Tomorrow, we're going to go over dilations again, and then we're going to go over the right triangle similarity example. And then the kind of review. On Friday, we're going to take a quiz. Okay. So tomorrow, we're kind of going to review and wrap everything up, and then Friday, take a quiz. All right.